Hello everyone, this is Jason Sykes, aka the Tech Rancher, with homework solution number 43. This course is done by Paul McCorder. It's called Raspberry Pi Pico W, and Paul does multiple different types of courses on YouTube. You can find him at the search of Paul McCorder, or you can go to his website at toptechboy.com. Alright, enough about Paul. Let's go to what I'm working on here. Hey everyone, it's been a while since you've seen me. Let me tilt this back a little bit here. Thank you. Alright, the homework was that we're supposed to put our MPU 6050 into a certain orientation or a condition that would read the X, Y, and Z axis into 0. If you remember from our right hand rule, we have X and Y and Z, and well, actually Z is up and down, so it's X, Y, and Z, and we have a gravitational pull constant of about 1g on our Z-axis pulling down. Now we have a plate over here. Let's see, represent this here. It's not going to come in very clear. I do apologize if I can get. Anyway, this is kind of let me point here that this is going to be our MPU 6050. This has three oriented plates, three plates that are oriented as Paul described. We have let's see, X, Y, and then we have a Z that's flat. And Paul showed also on a graph of rotating the MPU 6050 into different positions would give us different readings on one of those plates or multiple at the same time. This started making me think a little bit that Paul was going to try to show us maybe a certain orientation or a condition that would give us a steady 0 reading on all three planes. But after trying several times and doing drawings and looking at the math, which he told us in his video that we had the code was already set up, which is all it is reading the accelerometer of the X and Y and Z. So he said we already had the code done, the math was already done. It was just an orientation or a condition that would produce. The only way to defeat gravity is free fall at a certain time, because if we continue to free fall, we'll start reading a negative force on the plate of a z-axis. As we continue to fall, it will start reading the speed of our fall this way, which is minus the gravitational pull on that. So we'll actually, at a certain period of time of our fall, we will read 0 on the gravitational pull. If you're in space, you're constantly free falling back to Earth, and they figure out what position to put them at, that they constantly free fall at a same rate, and it never achieves the goal of getting back to Earth. This would be a steady state free fall. Now, if we were allowed to go up to space, or took this up to space, and put it at a correct distance where it would continually free fall, it would constantly read 0 on the X, Y, and Z. Well, on the Z, because we'd still have an acceleration force going around, so it would read that. But on a steady state, I don't know. Haven't done it, so I can't really tell you for truth there. But okay, so let me go to well, okay, I'll show you here on this first, and then I'll show you my orientation. So if we run this real quick, you can see that right now it's reading 0.0 or 0.85 or 84. That's my gravitational for where my location's at on Earth. Is reading a gravitational pull of a 0.85 G's downwards. Now I'm going to raise this up. You can see that I was moving it and drop it. You saw, which let me try to see if I can stop this at the correct time. There is a drop or a decrease in my z-axis as it was free falling. You can see it was 0.3, which originally it was 0.8. If I could stop it at the correct time, it would actually read 0.0 and then maybe some hundredth of a second or hundredths of a degree force. So that is my only solution for that. But I know Paul is trying to always make us think deeper and farther than what we think it should be. So I kept on thinking, he took the time to show us orientation and described how the plates were laid out. Maybe there's some tilt that would reduce the gravitational pull on these plate readings. And I'm going to switch to my camera here and start this back up, and I'm going to tilt it as a pitch, then as a roll, and I am achieving 0.5 on all three axes. So let me go back to where you can see here what I'm showing. I'm achieving 0.5. It's distributing the downward pull onto all three axes. That was the only thing I could achieve. I did that on a drawing first and realized that you can distribute the downward pull onto all three axes equally, and then went from there to figure out what kind of orientation that would be to achieve that, but never was able to get anything that would be zero at a constant steady rate. Alright, that's where I'm at, and that's what I went with, and I think Pyle is going to surprise us and show us something that we missed, but I'm excited to find out if that's true. If not, then hey, that was a good, easy assignment for our brain this time. Until next time, everyone be safe out there. See ya.